Welcome, welcome, welcome. In this video, we're going to talk about two-player games. So the first definition that we want to discuss in this topic is that of a winning strategy. Now, anytime in mathematics where we're writing down a definition, we want to be really careful with what that definition says. If we ever hear this word winning strategy again among the topic of two-player games, we are going to think back to this definition. So let's let go of our regular English meaning of the word winning or winning strategy. You might think of that and might say, okay, that's sort of a good way to play a game or a good strategy to use. But what we mean here is a strategy that enables a player to win no matter what move an opponent makes. So it's a guaranteed way of winning. You pick a strategy and it will always lead you to win the game. Okay, so there's 4 points that will be relating to a winning strategy. We're only going to discuss games in this section that are of the type in these 4 points. So first, games of perfect information. So there's nothing hidden. We're not playing poker where you have cards in your hand and you're hiding those cards from your opponent. While those games can still have strategy, we're not going to look at those particular games. Finite games, there has to be some rules in the games so that they don't go on forever. At some point they stop. So even if it's very unlikely that it will keep continuing on and on and on, but if it could keep going and going and going, we can't have that type of game discussed here. Or we're not going to discuss that type of game. So also we're not going to be rolling dice or flipping coins in our decision-making process. There won't be any chance affecting the decision-making process. You can think many moves ahead because it won't rely on luck. And finally, there's lots of games that could end in a tie, but we're not going to discuss those here. So we're going to avoid draw games. Or we'll design the rules so that there's always a winner. Now, if you stick all 4 of these together, the nice thing about it is you always get this winning strategy. So under these 4 conditions, either the first player in your 2-player game or the second player will have a winning strategy. So our attack on how to learn this subject area is we're going to look at some different games. Each game that comes up will have a little hint, and then we'll get some time to play around with it on our own before we discuss a solution to that game. So my first hint for this first game is that when looking for a winning strategy, sometimes a coloring or checkering pattern on the game pieces or the game boards can be very helpful. Now, this is not a absolute rule that you must always follow, but it's just a general helpful statement that can come up when you might be looking at 2-player games. So we're going to start by looking at the game of pick up coins. So there's 6 coins. They're lined up in a row on the table. Each coin has a natural number on it. So they're not like regular coins of like dimes, nickels, quarters. They have some natural number, in this case like 5, 6, 1, 4, 5, and 2 printed on them. And in a different version of this game, those numbers might be different. So Nora is going to play the role of our first player and is going to pick a coin from one of the ends of the row. So maybe picks 5. And then next, Abraham picks up a coin from one of the ends of the row. But if 5 is already picked, then of course that's gone. Then Abraham would have a choice among the rest of the 5 coins, but has to pick from the end. So could only take the 6 or take the 2. So they alternate in this manner back and forth, picking up coins. And then at the end of the game, the player totals. So the grand total of the natural numbers that you've collected is added up. And whoever's total is more wins the game. Now, remember how I said there's no tying going on, right? We're not going to end in a draw. So we design the game. So there's this rule. So the first player will win if there's a tie. So if the totals are the same our first player named Nora will win. So an example of how it can be set up is below. You could set it up differently. Our job is to try to find a winning strategy. And the winning strategy doesn't necessarily just work for these numbers. It should work for all arrangements of natural numbers with 6 coins lined up on the table. So I'll let you pause the video, think about how you might solve this, remember the hint that's above, see what you can come up with. Okay, so if we're ready for the solution, the first thing that we're going to do is checker the coins. Okay, so I've chosen to checker the coins blue and white. Now, on Nora's first turn, remember Nora has to take from the end either the 5 or the 2. If we ignore the numbers for the moment, ignore the 5 and the 2, Nora can either take a blue or a white. Let's say, for example, Nora says, well, the 5 is bigger, I'll take the 5. Now notice that Abraham can only take blue coins. Since Nora took a white one, only blue is available to Abraham. Then Abraham would have to pick a blue one. Let's say Abraham chooses the 6. Then choosing the 6, it reveals a white one for Nora to pick up. This pattern continues on so that Nora could choose from the beginning of the game if she wants either all the blue ones or all the white ones. So since Nora has that choice, and she would like to get the larger amount in the end, Nora can just pick up the larger group. Let's write that down. So for this example, Nora would look at a 5, a 1, and a 5 and get 11, and compare that to a 6, a 4, and a 2 and get 12. Nora would like the blue coins. So if we were to play this game out, Nora would decide to take the 2 first, and then Abraham would have to take a white coin. They're both 5. Maybe Abraham chooses the 5 on the right-hand side, not to reveal the 6 right away. Then again, Nora can choose between a white coin or a blue coin. Nora's already decided to take all the blues, so Nora will take the 4. Abraham is then forced to take a white coin and takes the 5. And then finally, Nora gets to take the 6, and Abraham finishes off the game taking the 1. And Nora's grand total is, of course, the bigger one as planned out from the beginning. And this strategy will work for different numbers as well. All right, thanks so much for listening. We'll see you on the next one.